Welcome to this session of CodeRage 7. My name is Girish Patil and I'm the founder of Gnostice. I'm glad that I'm still deeply involved with the R&D of the products at Gnostice because I can come and speak at CodeRage. At Gnostice, we create components to enable developers to integrate electronic document processing capability into their business applications. The processing includes creating, editing, converting, working with PDF documents, and much more. In this session, we'll take a short tour of the new Gnostice products and the new features we have added to existing products. To get everybody on the same page, we'll start with a quick introduction to the products, and then we will go into the demos of the new features we have added to existing products. After that, we'll come back a bit and look at the big picture on the vision for electronic document processing that Gnostice has. While we do that, we'll see demos of products that we have already realized of this vision, and these demos will be in Delphi Prism, while the demos in the first part of the presentation will be in Delphi. We'll then close with information on our roadmap and some CodeRage special offers and Q&A. Here are the products we have for Delphi. All the products are included in a suite called the Extreme Dev System Delphi subscription. They're also available separately. There is eDoc Engine, as the name may suggest, is the product for creating electronic documents, and let's take a look at its capabilities through this diagram here. So at the center are the document creation components, which can create all these formats, and you have the export interface components, which can help you interface with Delphi reporting tools and other Delphi third-party components to create these formats. And eDoc Engine itself has the capability of creating documents from scratch, exporting rich text files, and so on. Let's also quickly take a look at the code. So for exporting a report, all you need is to create your report, drop a few components like the engine component and the interface component, and wire them all up, and automatically we get the facility to export the report to the formats that we have enabled. And then there may be some specialized needs, like for example in a help authoring tool, our tools are used, and where they create meta files of the pages that need to be included in the document and simply play those meta files to generate the PDF or other format. Also, there are these methods for converting rich text files, and you can use any GDI command and directly draw to eDoc Engine's canvas. So it's actually compatible with the Delphi tCanvas. So any GDI command can be rendered on this canvas, and then you can create the format. Then you have the PDF Toolkit component. PDF Toolkit comes into the picture when PDF is the input to your business application, and the typical tasks that you would want to perform with PDF documents are something like this. You may want to extract text from a PDF document, so then you would simply load the PDF document and you could just call the save as text method. Or you may want to convert the PDF document to different formats. You can use PDF Toolkit for that. Or you may want to search inside PDF documents, reorganize PDF documents, and inspect or get properties of a PDF document. You may want to process PDF forms. You would do that this way. You would get the fields that are contained in the PDF document and then access each of their properties, set properties, and then after all the modifications you would save the PDF document. And then you have the PDF converter. If you want to import PDF into some help document or any other document, you would use PDF converter or Extreme PDF converter for that, and that's fairly easy to use. There's just one method to convert the document. So you supply your PDF document and specify your output rich text file name. And what Extreme PDF Converter does is it actually goes through the PDF document, because PDF documents don't have any concept of paragraphs or text alignment or numbered lists or tables and so on. So PDF Converter goes through the file completely and actually applies a lot of intelligence to check the patterns of the contents and appropriately converts them to a rich text file, which is nicely formatted into paragraphs, and where the alignment of the paragraphs are set, and if it encountered what looked like a list, it also sets the numbering, and then if it's a bulleted list, it identifies that. Tables, it identifies columns like these, and it does a pretty good job. Okay, here are the new features that were added into the new releases that are happening in November. So in eDoc Engine, there's a completely new Excel engine which generates the XML based format of Excel. So you can open the Excel documents now in Microsoft Excel as well as OpenOffice. Then there were some nice little features added. For example, there's a feature now where all images in the input document are scanned to see if they are repeated, and there's optimization taking place automatically that only stores a single image for all those repeated images in PDF and HTML formats. The other big feature that we added is digital signing and some others as well. In PDF Toolkit, the really nice feature that we added is Forms JavaScript embedding, and also there were good enhancements to the viewer where the rendering was improved, and the viewer now uses a background thread for rendering, so the scrolling is really smooth and there's no hold up of the user interface. Okay, so time to go into the demos now. So we look at these key features in the demos. So first we will have a look at the automatic image reusing capability of eDoc Engine, and then we will look at digital signing. So let's go over to Delphi and go through these demos. Okay, so I have a really simple report set up in Fast Report, and I have dropped these two components, the engine and the interface, and wired them up. Let's run it. We can see the report here. It's a fairly simple report with a repeated image, which is the logo in the header of the document. Okay, so now let's export this report to PDF and see what that feature is really about. I'm going to just leave it at the default file name, and it's going to go to the output folder. I say save. We can see this particular option here, which is basically the option for reusing images. So let's first see without turning it on. So let's say okay, there's a report generated. The output is very much like the report. Now let me do this again by turning on the option for reusing the images. So this time we'll say, just to identify the file better, we'll just change the name and reuse images. Okay, so it's the same report. Now let's just go and inspect the file sizes of both these reports. So the first one, as you can see, is about 900 kilobytes, and the second report, which reuses images that have been repeated, is about 1/3 the file size as the other one, which did not use this optimization. So you can see that this report is just 6 pages. So if reports go into hundreds of pages, which usually they do, then the file size can really grow if this optimization is not done. And one important thing to note is that eDoc engine does not have this information, or it uses actually meta files to generate the output. So there's no information that this part of the document is the header. It needs to inspect all the images coming in and then do a hash and optimize that. So it does that, and it actually turns out that it's quite fast at it. Next, let's look at how we can digitally sign a PDF document. But first, a quick introduction to digital signing. We'll understand this technology from the benefits it has for the common man, and we'll trace through a scenario where important information pertaining to a business is being sent across, and there are possibly three people involved in this: the sender, the agent for the sender or the intruder, and the receiver. So let's understand the requirement. So the requirement for both sender and receiver are these. The receiver should be able to know for sure that the information is authentic and that it indeed came from the sender and not from somebody else impersonating the sender. And then the second requirement is that the information was not edited or tampered with before it reached the receiver. And if it was tampered, the receiver should be able to say easily that the document was modified. Okay, so let's say the sender sends this information as simply a plain text document or any other document without doing anything special. So the agent or the intruder can easily modify it and send it across. So now the receiver gets the modified content and also cannot say that actually the document was modified or not. So the sender could get a little smarter, and then he could actually generate a hash of the content and send that across. Now that can easily be reverse engineered, so the sender or the intruder can actually modify the content and the hash and send it across. Again, the same problems for the receiver. Then you could use some more technology. So you could actually encrypt the hash using a password. Okay, the intruder or the agent can't do anything with it, or it's not easy to crack that, but the issue is that the password has to be now shared with the receiver. So it's the same password that the sender used for encrypting the document, which has to be shared, and the receiver now can do some mischief. So if he was dealing with somebody else, then he could actually make this document his own, and he could even modify it. Now we come to this technology which is known as public key cryptography. So in this, there are actually a pair of keys generated. So one is used for encrypting or while creating the document in the context of document signing, and the other is the key that is public, which is used for reading the document. There's only one key pair that can be used on the document for creating and reading it. So now the sender uses this technology, signs this document and sends it across to the agent, who has to hand over the document to the receiver. So the agent could read the document using the public key and actually create a new document or modified version of the document, sign it with his own certificate that actually has the sender's details. Now this could be done because the sender himself generated the signature and there was no third party involved. So the agent could also do that and send the document and the certificate across to the receiver. And since the receiver is getting the document from the agent, who is supposed to be the trusted agent of the sender, he simply trusts the certificate and uses it as if it's come from the sender. So to avoid all this, we have the trusted certificate vendor, which is actually a third party which issues these digital certificates for signing documents. So once you use a certificate issued by a trusted certificate vendor, you're fine. The document can be verified that it actually came from the sender, and both are happy, the sender and the receiver. I have a signed document here. Now if you see here, it says that the document has not been modified since this signature was applied. Now let's go play around a bit with this document. So I'm going to open this file in Notepad. So we'll just modify this document a bit. There is this producer name, so I'm going to just change it a bit and just change one character, then save it with a new name. I'll call this modified. Okay, now let's open this document, and if we see under the digital signatures tab, you'll find now that instead of a green tick mark there is a red cross mark, and it says document has been altered or corrupted since it was signed. So any modifications to this document, the receiver can know that it was modified. Okay, so now let us actually go and see this through eDoc Engine. I am already running this eDoc Engine project, so I'm going to again go do the export to PDF. Now let us use a new name. We'll call it design, and there's a new option here we can see called digital signature. All we need to do is turn on the digital signing, and we can choose to give a location so we can actually have it visible on the page, or we can choose to just keep it off. Now we need to give the certificate, and I hopefully know the password for that. I'm just gonna put something in here. Reason to demo maybe, and location is CodeRage. Keep the date as it is and say OK. Now the document was generated and it was signed. You can see that everything is fine. This can also be done by accessing the properties in code. So if we turn off the dialog and we want to do this, we can still do this by setting the appropriate digital signing properties. So we have to enable it and then set the necessary signature properties. Oh, I'm letting out my password. Okay, so time to move into the next demo, and that is about embedding JavaScript in PDF forms, and we will see this through PDF Toolkit. So before we do that, we need to go through some fundamentals of PDF JavaScript. So let's see why this technology is needed in the first place. So just as in HTML, we use JavaScript to make our web applications easier to use and more interactive. For the same reasons, we can use JavaScript in PDF documents to make them more interactive and easier to use. Here are some examples. One may be to automate some tasks. For example, when a document is open, you may want to print it, and I have such a document here where JavaScript has been embedded in the PDF to print the document when it's open. So this one, when I open this document, it immediately pops up the print dialog. We may want to selectively enable some content on the PDF. So the PDF may be a questionnaire where, based on some questions or the input to some questions, we want to enable some other questions on the PDF. We can do that using JavaScript. We can also improve the usability of the document. For example, we can set up the formatting of fields. We can set up fields that calculate automatically and so on. Okay, so how is it done? So just as in HTML, PDF provides a document object model to access elements in the document from our JavaScript code. And the diagram that we have here represents the PDF DOM. It consists of 7 types of objects, and through them we can access every element of a PDF document. Today we will deal with the field object mostly, so let's understand this a bit more. Now the programming model is very similar to that of Delphi, but the naming is a bit different. Let's understand this keeping the Delphi component as our reference point. So starting from the top, so the PDF object in this case our form field is similar to a Delphi component, let's say an edit control. Just as the Delphi control has events, PDF objects have triggers, or that's what they're called in PDF terminology. So a field has a keystroke trigger, which roughly corresponds to an edit control's on key press, and actions in PDF correspond actually to the event handler and the code we write in those event handlers. So there's triggers which are similar to events, and there are actions which are similar to the event handlers and the code we write in them, and the actions actually more closely correspond to the T action and its descendants as in Delphi. And these actions in PDF are generally of two types. So one is the predefined type. For example, there are some actions provided by PDF to go to a page or go to a web link and so on. And then there are custom actions which are written using JavaScript, and in those custom actions you can use predefined functions, or you can define your own functions to write the JavaScript. And one important thing to note is that you can have multiple actions set up on a trigger, so all of them will execute one by one in the order that it was set up. So this is what the PDF format provides us. Now let's look at what PDF Toolkit provides for us to be able to embed JavaScript inside the PDF document. There's one point to note here. There are no predefined actions for form fields that PDF provides. All behavior has to be coded using custom JavaScript, including formatting and validating the input in form fields. However, PDF Toolkit provides some predefined action classes to validate and format form fields. Just as in Delphi, there are standard action classes for dataset events, for example. And the best way to understand this is to follow the steps it takes to embed custom behavior on a form field. So let's see. So the first step is to access the form field so we can do something to it, and we do that in PDF Toolkit by calling the methods to get the form field. We call the methods on the PDF document object. So there's a get form field method, one for getting the form field by index and another by its name. So once we've got the form field, we need to define the action that will take place on some event. So we do that through these three classes, creating an instance of one of them. So we have the base class, which is the JavaScript action, PDF JavaScript action, which is what we use for custom behavior. And PDF Toolkit introduces two new classes, one for validating and formatting form fields and another for setting up AutoCalc fields. So once we have created an instance of one of these classes and then written the necessary JavaScript, we need to associate the action to the form field and the appropriate event or the trigger of the form field. And we do this by calling the add action method, passing the action object and specifying the trigger that we want to associate this action with. Okay, once we have done that, we need to simply add the form field to the document if it was a new field, and we can do that by calling the add form field method on the PDF document object. And finally we can save to file or to stream. Now let's go over to Delphi and see this in action. So I'm going to just run this demo and execute a few JavaScript embedding commands, and then we will go over to the code and see how it's done. So I'm going to invoke the first option to use the custom JavaScript class and embed some JavaScript in it. I'm going to just select some file and the output file for it. Probably I'll just call it JS1. Save. Then the second one, load the same document and call it JS2, and then maybe the AutoCalc, call it JS3. Okay, now let's go and open these files and see what has happened. So the first one, which was supposed to introduce some validation, now you can see that it only accepts numbers, and if I press any letter it won't accept it. And I also think there's a range in there. Yeah, so it can only accept numbers within this range, 1 to 10,000. And let's see what the second PDF is about. It's again number validation and only numbers within -100 and 100. So this will work, and you can see there's some custom behavior on this. So if it's a negative value, then the color is set to red, and also there's range validation. And the third one, which is the auto calculation, so let me just enter some numbers. So these are the two input fields. I'm going to enter some numbers, and you can see that this sums up the two fields, and this one gives us the average. So if I change that a bit, you can see that the average changes and the sum changes as well. Now let's see the code for actually doing this. Okay, so the first option was to use the custom JavaScript class and embed all this formatting and validation behavior. So there's the form field which we are creating. So we loaded a new PDF document, we created a form field, a text form field, then we create a PDF JavaScript action. We need to know the JavaScript functions for it. So this is the function for doing the formatting, so limiting to 2 decimal places. This is the function to use. So we set that on the JavaScript property of the object. Then we want to allow only numbers, so there is this function which we use, the keystroke function, and these properties, one of these properties specify that we can only accept numbers, and another JavaScript for specifying the input range. So that is this function, and the range is specified through the parameters. And we finally add all the actions to the form field using the add action method and specifying the trigger that we want to associate this action with. And there are these standard triggers that are there on a form field. And then we add the form field to the document, and we saw the behavior of that. Now the same thing, so this was using the base JavaScript class and call all these functions to actually get the behavior of formatting the form field and validating it. Now the same thing can be done using the enhanced or the descendant classes. So in this case we again create a form field and we create the new class that PDF Toolkit provides, the validate action, and we set the input type specifying that we just want numbers to be input. So there is numbers, then percentage and date, time, and other possibilities. Then we specify the range. As we saw, we were only able to enter numbers between -100 and +100, and then we wanted some special behavior when the number was a negative number, and then we add the form field to the document and save the document. And then for setting up the AutoCalc fields, we had two form fields that were input form fields, and then we had two more form fields that actually showed us the average and the sum of the other two form fields, or the input in the other two form fields. Okay, so there's standard validation on the two form fields, the input form fields, and then the AutoCalc happens this way. So we create an object of the AutoCalc action, and then we specify which fields we want to actually consider when we need to perform the operation that we want to perform for the calculation. So we have some standard operations like sum, average, product, minimum, maximum. So once we have set up all that, we add the action to the form field. So that was about embedding JavaScript in PDF form fields. Let's see what else we have. So yes, we were going to see the new PDF viewer. Make the viewer as my default project. Let me run it. It compiles, runs. Now let's open some PDF files and see how the viewer performs. Okay, I'm going to select this one. So you will notice in this new version of the viewer, first of all, the rendering is really fast, and also the rendering is happening in the background. So as we scroll, the pages that are needed to be displayed are processed and rendered onto screen, and in a different thread from the user interface thread. So the rendering is happening in the background, but it does not stop the scrolling of the pages in the viewer. So as you've seen, the Gnostice components have a lot to do with electronic documents. So we want to provide components for business applications to deal with the entire life cycle of electronic documents. So the life cycle generally begins with the creation of the document, and then you want to view it, print it, you want to convert the document, you want to edit the document, and there can be many other possibilities. So what are our design goals for this product that we call Extreme Document Studio? So first of all, we want to be able to handle multiple document formats in a single tool. We want to be able to address all the document processing needs. We want to make it really easy to use, so the developer does not have to worry about the internals of the format. They just need to know what they need to get done. So for this, we have the high-level APIs, and if somebody wants to go deeper inside, there will always be the low-level APIs, and we want to make it extendable so users can build plugins for this framework. So we chose to first tackle the viewing and printing operation, because so that would involve the understanding of the document format itself. So if we solve that, then we have actually implemented all the elements that the document can contain. So let's see what we have achieved in this area of the new product. So I go into Delphi Prism. We have a viewer application here, which is using the document viewer from Extreme Document Studio. Let's run this quickly and see what it can do. So I'm going to first open some Word documents. So this is an example of a document that contains a lot of lists, and Extreme Document Studio is able to handle that quite well. So this viewer as well implements background rendering, so there's no hold up of the user interface while the rendering is taking place. Let me load another document which contains some images. another one, and now let me also open a PDF document, because this is already a multi-format viewer now. So it supports currently Word documents in the docx format and PDF documents. So you can see the rendering is pretty good, and also the scrolling is quite smooth, again with background rendering. Right, so let's go look a bit at the code. So the viewer, similar to the PDF viewer in PDF Toolkit, has methods for implementing some standard behavior on a viewer. For example, for navigating the page, you have the necessary methods, and that's basically it in this viewer. So you load the document, it figures out what document type it is and then calls the appropriate processor for it. So we are done as far as the demos are concerned. So here's what our roadmap looks like. So through this month we will be releasing the new version of eDoc Engine and PDF Toolkit, and through the next year we will have Extreme Document Studio for Delphi as well coming up, and a really exciting time for us, because this is something which we have been really looking forward to provide a single product for working with multiple document formats, and to be able to support all the operations on the document that any business application would like to perform. The special offer, a $100 discount on the Extreme Dev System, which contains all the Delphi products. Thank you for attending this session, and we are open for Q&A now.